Hello, classes, and welcome to today's session of pre-calculus. There we go. Right, I thought we would just do our mid-unit review here. So normally this would be a review that we would do right before a quiz. What I'd like you to do is just take a sheet of paper. You can write down some of these problems and pause this video as I go through them. All right, so why don't we start with some limits? Let me put it on the pen here. So again, what I'd like you to do is go ahead and copy down this limit. Why don't you take a couple minutes to work on it, all right? And you can pause this video, and I'm going to go ahead and work it out. Okay, this is one of our limits as x approaches infinity. So when you have the fraction here, we said what you really want to look for is the highest degree. That'd be the highest degree in the top and the highest degree in the bottom, because they're the ones that are going to hit infinity long before the other terms do. So in essence, these terms here have no bearing on the answer. If you reduce this fraction, you will get 5 over 2 to the x. We can plug infinity in here, and that would give us 5 over double infinity is infinity, and we know any constant over infinity, let me give you the right answer, is equal to 0. So we get 0 as an answer here. Right? You could have also divided by the highest degree, right? And that would give you the same result. Okay, second one. Again, copy it down. Take a minute to evaluate. This is another one. X is approaching infinity. The only things that matter to us is the highest degree. We have 2x cubed over 5x cubed. The x cubes will cancel out, and the limit, or the target, this fraction should be getting closer and closer to 2/5 as x is approaching infinity. Third one, now you're headed towards a finite number, different set of rules. On this problem here, I'd like to plug in x equals 2 into the bottom, but if I plug 2 into the bottom, I'm going to get 4 plus 2 minus 6, which gives me 0. All right, and I can't get x equals 0 there. Whoop. So what I need to do is factor this. The limit as x approaches 2. The top we can factor by SOAP, or difference of 2 cubes. X minus 2 times x squared plus 2x plus 4. The bottom is just unfoiling, or product sum method. X plus 3 times x minus 2. X minus 2's will cancel out. And now if you substitute 2 up into the equation, you can get 4 plus 4 plus 4 over in the bottom. You will end up getting 5. So 12 over 5 is what the limit would be here as x approaches 2. Now remember, if you were to graph this, there would actually be a hole in the graph when x is equal to 2. But you would be able to see from the left-hand side and the right-hand side, you're headed to 12/5. This is another one where I want to factor. The limit as x approaches 3. x minus 3 times x plus 5, x minus 5 that is, and x minus 3 times x plus 10. Reduce, substitute, -2, 13. -2/13 is what we end up getting as our limit. So as you're looking at this is another one as you're headed a finite number, but notice I only want to know the left-hand limit. I want to know what's happening before the number 4. 3.9, 3.99. As x approaches 4 from the negative side, what is this fraction headed towards? Again, I can't plug x equals 4 into my fraction, or I'm going to get 0 on the bottom of the fraction. I can't factor. This would be an example where you'd want to set up a table for x's and ask yourself, what is this fraction or what is this limit headed towards? 3.9 would be a number just before. 3.99 would be before. 3.9999. Put as many 9s as you want. I'm going to put 4. Now this is one I actually don't need a calculator on. If I plug 3.9 in for x, I'm going to get 10.9 over 3.9 minus 4 is a -0.1. Move the decimal over 1, move the decimal over, and I get -109. And I can do that for the next two also very easily without a calculator. If I plug in my 3.99, I can get 1099. And if I plug in my 4 9s, I'm going to get 10 and a 9999. Of course, I better not lose my negatives, right? So my limit here is -infinity. So as my x's are getting closer to 4 from the negative side or the left-hand side, my y values or my fraction here is getting closer and closer to -infinity. I would imagine as x approaches 4 from the positive side, you're headed towards positive infinity. Okay, find the derivative. So we have two ways to find our slope formula. We can either use the definition of a derivative or we can use the power rule. Now this fraction or this function I can rewrite like that, but it still doesn't allow me to use the power rule. And I'm not allowed to just distribute the 1/2 through the parentheses when I got an addition sign here. So let's make sure that we are using proper math there. All right. So I can't simplify this to put in the form where I'm going to use the power rule. I would have to use the definition. For the definition, we need the original function, and then we need to know what is the function when you plug in x plus h. 3 times x plus h plus 8. And then you plug them into your definition to a derivative. The limit as h approaches 0 of f of x plus h plus 8 minus the original function all over h. Now, this is a problem where you would have to multiply by the conjugate. I'm going to clean this up a little just so it looks better. There's my 8. So my conjugate is the square root of 3 times the quantity x plus h plus 8 plus the square root of 3x plus 8. And I'm going to get rid of some of this just to give myself some room here. All right, so my conjugate, all right, and of course I probably wrote that in a bad place. 3 times x plus h plus 8 plus the square root of 3x plus 8. So I'm going to multiply the top of the fraction by that. And I would have the limit as h approaches 0 of, all right, first term times first term gives me what's underneath the radical, 3x times, or 3 times quantity of x plus h plus 8. The inside and the outside term should cancel, and my last terms minus parentheses 3x plus 8 all over the denominator, which would have been h times that conjugate. All right, on top, I got the limit as h approaches 0 of, see if I distribute the top 3x and then I got a minus 3x that cancels, I got a 3h. And then I've got an 8 minus 8, which cancels. The only thing I should be left with is a 3h. On the bottom, I have h times the entire conjugate, and just because I'm going to run out of room, I'm not going to write all that, right? But I understand this conjugate is in here. And then I am going to cancel this h with this h that's on the outside. So what I'm left with is the limit as h approaches 0 of 3 over the conjugate. Okay, I'm going to get some room back here. Three over the conjugate. 3 times, you know what, let's do this the right way. Y prime equals the limit as h approaches 0 of 3 over my conjugate. And now I can plug in h equals 0, and I get 3 over the square root of 3x plus 8 plus the square root of 3x plus 8. Or in other words, as my derivative, I get 3 over twice the square root of 3x plus 8. And remember, you can leave radicals in the bottom of the fractions at this point. Okay, same question. Find the derivative. Now I can use the power rule. Again, you should be pausing and working out each of these problems and then coming back to check your answer with mine. In a calculus class, when you learn all the other shortcuts like the power rule, it's going to make problems like the last one a lot quicker for you. All right, we like these shortcuts. This one here I have to rewrite first. 2x cubed plus 4x to the 1/2. So now when I'm looking for my derivative, I've got 6x squared. Half of 4 gives me 2. Subtract 1, I get x to the negative 1/2. So it's a final derivative. And that x to the 1/2 you could write as the square root of x also. Number 9, you need to rewrite also y equals 6x to the negative 3, which makes y, that's minus 3, which makes y prime a negative 18x to the negative 4, which means y prime is a negative 18 over x to the 4th. And then the last one I have for you, write the equation to the line that's tangent to the following equation. Here's our point slope form. See, when x is equal to 4, I do have to know what the y is. So I would take my x equals 4 and plug it into the original equation. If you do that, you should get 24 1/2 back. Then I need to find the slope. So for that, I need my derivative. Y prime equals 2x plus, now this term here is 4x to the 1/2. So my derivative would be 2 over x to the 1/2. My last term here I can write as 2 times x to the negative 1. So my derivative there would be negative 2 over x squared by the time I clean up the negatives. And then we need to know the slope at 4. If I plug in 4, I'm going to get 8 plus 2 over the square root of 4, which is 2. 2 over 2 gives me 1, minus 2 over 4. I'm sorry, 2 over 16, which gives me 1/8, which would leave me with 8 7/8. So my equation is y minus 24 1/2 is equal, this is getting ugly, which is equal to 8 7/8 times x minus 4. Okay, and we are done, right? Those are all problems that you should feel pretty confident with at this point. All right, next time I see you, we'll start into the second half of this unit here, and we'll start talking about some max and min problems. Everybody take care.